our group would like to do an experiment on the removal of oxygen from hydrogen peroxide, which is called the colored foamy fountain. Before the start of the experiment, I'd like to introduce the safety precautions. Hydrogen peroxide may be irritant. Therefore, we need to wear safety goggles and protective gloves if necessary. Also, a large amount of foam may be produced. Hence, step back a little when the reaction between hydrogen peroxide and the yeast mixture begins.
In the experiment, we need the still water, both cold and hot. We also need yeast, soap, hydrogen peroxide and some food coloring. We have two straws to replace dropper, some cups, a teaspoon and a measuring cup. First, measure 3 teaspoons of yeast. Add in the still water to dissolve the yeast. Measure 20 milliliters of hydrogen peroxide. Pour all the other materials into one cup. 5 drops of soap. Add 2 drops of food coloring. Pour the yeast into the solution and reaction starts. It had risen to 9 centimeters. Repeat the above steps with different concentrations of hydrogen peroxide. solution and reaction starts. This time it rises for 7.5 centimeters.
When the mixture of yeast and water is added to the solution of hydrogen peroxide, dish soap, and food coloring, large amounts of foam will come rushing out of the container. As a result, a colored foamy fountain is created. Consider the following equation. Hydrogen peroxide breaks down to give water and oxygen. The yeast added works as a catalyst to remove the oxygen molecules from the hydrogen peroxide solution. As a small amount of hydrogen peroxide generates a large amount of oxygen, huge amounts of oxygen released will be trapped by the dish soap, creating air bubbles and forming foams eventually. The use of food coloring is to dye the foam produced from the reaction. As a result, a column of colored foam will come rushing out of the container. Now we would like to talk about the calculations involved in this investigation. First, let's find out the molarity of the hydrogen peroxide that we bought. The percentage by mass of hydrogen peroxide in the solution is 3%, and the mass of the hydrogen peroxide in 20 ml of solution used is 0.6 grams, and the number of moles of hydrogen peroxide in the solution is 0.0176 mole, and the molar mass of hydrogen peroxide is 34 grams per mole. Eventually, we got the answer of the molarity of the hydrogen peroxide solution bought, that is 0.882 m. For the first dilution we did, we had added 50 ml of hydrogen peroxide and 5 ml of distilled water. To find out the molarity of the diluted hydrogen peroxide, let M2 be the molarity of the resultant solution. By M1V1 equal to M2V2, we calculated the answer of M2 is 0.662 m. Hence, the molarity of this diluted H2O2 solution is 0.662 m. For the second dilution, we added 10 ml of hydrogen peroxide and distilled water together. Then, we are going to calculate the molarity of this diluted hydrogen peroxide solution. Firstly, we let M2 to be the molarity of the resultant solution. Using M1V1 equal to M2V2, we calculated the answer of M2 is 0.441 m. Therefore, the molarity of this diluted hydrogen peroxide solution is 0.441 m. Now we are going to share some findings in this investigation. From the bar chart, we found that the original solution, which has 0.882 m, produced the highest height of foam produced, that is 9 cm. Following by is the dilution 1 that has the molarity of 0.662 m, and the shortest height of foam produced by is the dilution 2, which has the molarity of 0.441 m. The molarity of the hydrogen peroxide solution used in each of the experiments is decreased proportionally, as the differences you can see below are all 0.22 m. However, we found that the decrease in height of the foam produced is not decreased proportionally, for the difference in height between the first experiment and the second experiment is 1.5 cm, and the difference in height between the second experiment and the third experiment is 0.8 cm. So we thought that this may be caused some experimental errors that we made, which includes the inaccurate measurements in preparation of each mixture, or the rough dilution of hydrogen peroxide solutions. From this investigation, we found that the more concentrated is the hydrogen peroxide solution we use, the higher is the foam produced in the reaction goes.